Find the maximum stirrup spacing in inches. In this problem, a simply supported beam has a midspan point load of 90,000 pounds. The concrete compressive strength and the steel's yield stress are provided, as well as the beam width and depth to tension steel. We also know the stirrups are number 3 sized rebar. When calculating stirrup spacing, the first thing to check is whether or not stirrups are even required. Stirrups are only required if the shear force in the beam exceeds the minimum shear force, Vmin. From the shear force diagram, the maximum absolute shear occurs along the entire length of the beam and equals 45,000 pounds. The minimum shear strength requiring reinforcement equals 1/2 times phi times the shear strength of a purely concrete beam, Vc. The problem statement provides us with phi as 0.75. Vc equals 2 times the square root of f prime c times b times d. For this equation, the units for each variable are shown here. Once the values for each variable are plugged into the equation, the shear strength of an unreinforced concrete beam equals 49,584 pounds. Plugging in this value for variable Vc and 0.75 for phi, the minimum shear, Vmin, equals 18,594 pounds. Therefore, we know that stirrups are required to resist the applied shear force in the beam. The stirrup spacing, S, equals the minimum of 4 separate criterion according to ACI standards. From the problem statement, we already know the variables except for variable AV, which stands for the area of steel in a single stirrup. This steel serves to resist the shear force developed in the beam. Since the stirrups are number 3 sized rebar, they have a cross-sectional area of 0.11 inches squared per bar. Therefore, the area of steel in a single stirrup resisting the shear equals 2 bars times the area of steel per bar. This equation uses 2 bars because it is assumed the rebar wraps around all the longitudinal reinforcement bars, thus making 2 vertical passes through the beam. The area of steel in a single stirrup resisting shear equals 0.22 inches squared. Plugging in this value for variable AV as well as the other variables, S equals the smallest value between 19.9 inches, 18.9 inches, 14 inches, and 24 inches. Therefore, S equals 14 inches. We'll run one last calculation to ensure 14-inch spacing will provide adequate shear resistance in the beam. From the shear diagram, the shear in the beam equals 45,000 pounds. And we can also recall the values of phi and the shear strength provided by the concrete, Vc. Vs is the shear strength provided by the steel stirrup and is a function of the area of steel in the stirrup, yield stress in the steel, depth to tension steel, and stirrup spacing, and equals 26,400 pounds. Plugging in the values for phi, Vc, and Vs, the maximum shear resisted using 14-inch spacing equals 57,000 pounds, which is greater than the applied 45,000 pounds, and greater than the calculated minimum of 18,600 pounds. Therefore, our stirrup spacing of 14 inches is the correct answer. When reviewing the possible solutions, the answer is C.